When we go from polar to rectangular, we have a little bit more work to do. We have actually more manipulation to do before we can start subbing things in. So if we come out at these like this with the same mindset, we're looking at this saying, I don't want that r there anymore. I only want x's and y's. Do you guys see anything right here that will allow you to sub out the r right away? This one right here? Now that says r squared though. That doesn't say r. So can I manipulate this?
Yes.
What can you do to both sides? You can square it. And so we have r squared equals 100. Alright, do we know what r squared equals with the x's and y's? X squared plus y squared equals 100. Boom. There's no more theta, no more r. It's in rectangular form. Do you guys know what that graph looks like? That's a circle with a radius of 10. Now that's our goal too. It's not just to get rid of the r and the theta. We also want it in a form that we recognize. We recognize that form. That's a circle. Okay, let's look at this next one. This is kind of interesting. There's no r here. So what is that line going to look like? Is it going to be all curvy? Is it going to be a flower? Is it going to be like all fancy like? Well, let's find out. Is there a way to get rid of this theta? Tangent. Oh, so we could take the tangent of both sides. Okay, so let's try it. We take the tangent of the left side, so we get tangent of theta. And we take the tangent of the right side, tangent of pi over 6. This we can now take out. What does tangent of theta equal? Y over x. Okay, right? We're using this guy right here. Now what is tangent of pi over 6? Okay, now if you didn't know, which is me, like it takes a little longer for me to think about it. If we look over at pi over 6, do you guys remember the coordinates on the unit circle for pi over 6? Because I'm spatial, I can see that in my head pretty clearly. Rad 3 over 2 and... Okay, now tangent is this divided by that. It's the y divided by x. And so we can go 1/2 times the reciprocal of that, because whenever you divide a fraction, you multiply by the reciprocal. So it's 2 over rad 3. So now with the 2's cancel out, we're left with 1 over rad 3, which is rad 3 over 3. Or you can leave it as 1 over rad 3, but I'm going to go rad 3 over 3. Okay, now is this in a form that we recognize? No, we got rid of the theta. I mean, there's no r here, but it's not in a form we can recognize. So what do you guys want to do to this to try to make it multiply by x? Let's see what it looks like. If I multiply both sides by x, these x's go away. And I'm left with y on the left side. And on the right side I have rad 3 over 3 times x. What does that graph look like? That's a linear function right there. This is just the weirdest slope I've ever seen. We've never seen a slope like that. We don't work with that stuff in Algebra 1. So that is a line. Okay, so for this next one, we have the r and the theta. Now we want to try to find a way to manipulate this so that we can substitute something out. Now remember the trick that we did before with the r squared? What do you guys think? You guys want to do that?
No.
Okay, hold on. I'm going to do it, but I'm going to kind of speed this up a little bit. Our other class, we kind of went a little too far with it. But if I square both sides, it's going to look like this. R squared equals 9 cosecant squared theta. Ew. Okay, but the next thing you would do is, right, you would take this out and you plug in x squared plus y squared. The problem is, once you sub that out, like, it didn't solve our problem. We still have a theta right here. And so maybe you thought, well, how can I get tangent? How can I get a tangent here so that I can sub out the tangent? Ah, see, you're doing good. Okay, it's going to get really bad. Okay, and I'm going to stop you guys right here because I don't think the other class liked it very much when I let you guys keep going. There's another way to do this. Instead of squaring both sides, what's another way we can get r squared? Multiply both sides by r. And some of you guys figured that out, which is awesome. And some of you guys did it because you guys looked at the examples and you studied last night. Very diligent. Awesome. If I take both sides and multiply them by r, I have an r squared here, and on this side I have a 3 times r times cosecant theta. Now these three terms that we're multiplying together, it doesn't matter the order that you put them in, but you'll notice that when I put them in this order, you notice something right here.
You can't do anything.
You guys notice this? Okay. Now what's another way we can write cosecant? 1 over sine. So this is 3r times 1 over sine theta. You guys got that? Okay, this is r squared right here. What do you want to do next? You want to take this out? Put x squared plus y squared? What about this side? Alright, so I led you down another rabbit hole. But, guys, this is important. Sometimes this happens. When you're going through a problem, it starts getting really nasty. And you start getting down this rabbit hole that's like way too deep. So sometimes you got to go back and see if there's another approach that you can go. Now, let me go back. I'm going to say let's not multiply both sides by r. Let's take this guy right here and change him right off the bat. Instead of having a cosecant, let's have a 1 over sine. So I have a r. Let's see. We're going to scratch this way. We have an r equals 3 times 1 over sine theta. Can you get rid of this this fraction here by multiplying both sides by sine theta? And that would go away, right? Then I multiply this side by sine theta. Ah, r sine theta equals 3. And what is r sine theta? So we just sub this out right here. Kind of cool, huh? I know, you guys thought it was way tougher, didn't you? Yeah, but we spent a lot longer on it. They got mad.
She has a better way to do it.
Oh, you have an even faster way? Oh, you did it the same way? Yeah, the other class, they got really mad because I filled up this whole thing.
But did you know how to do it already?
Yeah, I just... Yeah. It's important, though. It's important to sit here and play with it. Because if you get this, like, if I just give you the answer every single time, you guys think that you're supposed to just know it like that every time. All right, let's take a look at this one. Let's see what we can do to this one. Okay, so this one over here, I'm looking at it. R is right here, theta's right there. We got to get rid of this cosine somehow. So maybe to get rid of that cosine, we're going to use this guy right here. Oh, just maybe this guy. I'm pointing at it. So what can I do to both sides? Oh, I heard...
Divide by 6.
You want to divide by 6? I heard multiply by r. Divide by 6. What do you guys want to do?
R.
Okay, let's try it. Let's times r times r. So we have r squared equals... What's r times... Well... times this. I'm just going to reorder it here. Negative 6 r cosine theta. Now we have this guy right here. Because we multiply by r, you guys know what this equals, right? Okay, so this equals negative 6x. Okay. And then can we take this guy out too? Okay, let me clean up some space here so I can have more space to work. Okay, so now... we got rid of the theta, we got rid of the r. Is this in a form that we recognize? No. Now, if you remember conics, which was a long time ago, we could put all the terms on the same side, and it would look like this. X squared plus 6x plus y squared equals 0. And this kind of starts to take shape. We're going to have to complete the square here. You guys remember completing the square? Because this one right here has an x term, we're going to complete this square for that one. We don't have to do this one, because that one's already a perfect square. So let's make this a perfect square. That's going to be x squared plus 6x plus, what are we going to add to that? 9. We take the 6, divide it by 2, and then square it. That's how you complete the square. Now it's a perfect square trinomial. Why do we want a perfect square trinomial? So we can write it like this, x plus 3 squared. because that would be more like conic form. Now this is where I did make a mistake in my first period class. What did I not do? I gotta add the 9 to the other side. If you add 9 to one side, you have to add 9 to the other side. This is where I did make a mistake. I'll be honest with that. Okay, and so now we have a 9 on that side. We have 2 perfect squares right here. Do you guys know what this shape is?
Circle.
It's a circle.
It's a circle with radius.
Of trees.
Radius equals 3. Ooh, that's interesting. All right, someone say tree. All right, very good.